3.
Alright everybody, so we are down to our last individual, and today Mike is going to be talking about his robot.
Okay, so unfortunately things do break sometimes, or they just don't flat out work. In this case, that's what happened with me and my robot. I went through some few complications in the beginning. The first struggle that I had to overcome was I ordered my robot on Tuesday of last week, which I knew would give me plenty of time to work with it. For whatever reason, it ended up getting delayed until the Tuesday of this week. So I was working on a major time constraint, unfortunately, but I was getting through it, or I thought I was, until I ran into some issues. So some of the issues that I ran into were device drivers, operating system issues, as well as some software issues. So one thing that I'll explain to you guys really quick is COM ports. So COM ports are a input-output device on a computer. And now those are managed by the operating system, and sometimes software will also help to manage those. Unfortunately, what was happening in my case with my robot is it had two separate COM ports that it was attached to, so they were interfering with each other. And that was causing any code from being uploaded to the board, so it would fail. I spent quite a lot of time on this, pretty much this entire week, ever since I got the robot, trying to figure out what I could do and how to fix this. At first I thought it might have been a driver issue, so I went ahead, disabled the device and uninstalled all the drivers, and then found independent drivers for it. Fortunately, it still wasn't working. I realized that the root of the problem was because those two devices were on the same COM ports. Like we've learned in our CNS course here, you have, what am I going to say? So you have COM ports, and these devices connect to them, right? So unfortunately, what was happening is the bootloader, like we learned in Rich's class, right? It gives programs and then it runs those programs. Unfortunately, that bootloader was not being detected by the software. So when I went to upload that code, it wasn't uploading that code to the board because the bootloader didn't want to connect to it, didn't want to give the code to the board. And so that was the main issue that I ran into throughout this entire process. And unfortunately, I couldn't figure out a way to get it to work. But I will go over a little bit of the bot I chose. Unfortunately, I don't have it with me. So the bot I chose was the ArcBot Sparky. So this is a 10 and up bot. It was $150, so it was a little expensive. The reason I chose to go with it, even though it's price tag, is because I figured if I was going to use it once, I might as well get multiple uses out of it as well. So I went with something that was quality. It was kind of expensive, but it was going to work with me in the long run, and I could learn from it more. So our product Sparky is programmable through Arduino, which is a type of board system like many of my peers have used. And so with that, it's compatible with C++, which is another coding language, as well as block coding, like Ian explained. So that's some of the features of it, as well as it does have an ultrasonic sensor like most of my teams have had as well. It does have tracking for lines like this. And all of this is managed by the Arduino board and the code that you upload to. So this is a quick video on the object retrieval that it has. So we'll go ahead and have Alex play that for you guys. Yeah, so everything that's being utilized in this is all the basic movements of the bot, as well as everything that you guys have done. Specifically, your teams, Robert, with the maze tracking, and then what would have been similar with Joel's robot with the grips. So the ultrasonic sensor is detecting the block, right? And so that's working by sending out signals, and those signals bounce back. Detector receives it, and then tells the robot to stop within a given parameter. Once that code has been executed, then we'll execute the code to bring the pinchers closed. And all of this is done in C++ or through blocks. But on the back end of the blocks, it's still the same code. So it goes through that process, and then obviously follows the lines of it's turning around and continuing throughout the maze. And as Robert explained, the sensors used to guide it through a maze or on a track is a simple laser detector, and it just senses where it is on that track, and if it's in line, keeps going. So yeah, unfortunately things didn't work out for me. I tried my best to work through all my problems, but I definitely followed all the steps of troubleshooting, and unfortunately sometimes things just don't work out the way you want them to. But next time, definitely going to spend a little more time on just getting things ready. Time management was something I definitely need a little more work on with this project. But in the end, I felt like I did the best I could, and unfortunately, it just wasn't enough, I guess. And sometimes things like these happen, and sometimes you don't really have an answer to that. Thank you for listening to this When Things Break presentation, guys. Thanks so much. Any quick questions?
Thank you. Thank you for going over the troubleshooting process and those areas that you saw were opportunities for growth. Could you tell me the impact of the color of the line? What impact does it have on the robot being able to follow it?
Yeah, so for example, actually, you can see down here on this carpet, so you definitely have to have contrast with the object as well as the line that it's drawn on. Otherwise, those sensors won't be able to pick that up. So if you have black on black or gray on black like this, the robot won't be able to distinguish where it is on that track. So having high contrast is definitely something that's really important, especially with robots like these. These aren't as high tech as a lot of those big STEM robots you see. So the capabilities are much less high as they are with those more professional robots. Lowest from the 9.
Did you get a refund?
I might be able to.
Alright, Mike, so I see your robot is able to move the object. Does he have like the maximum weight or the maximum object weight?
It wasn't specified in any of the specs of it, so I'm not really sure about that one. The robot is probably like maybe a pound, so I'd imagine it probably can't lift anything over 3 or 4. But that would definitely be an interesting thing to see how much it can move. Is that it? Thank you, guys.